En la clase anterior les dije que vamos a ver tres grandes temas. Uno, para empezar, es los autómatas finite state automata, que son los autómatas de estado finito. Ese va a ser el tema del primer parcial. Luego vamos a ver gramáticas libres de contexto. Entonces, context.
Frank,
¿Sí?
¿estás compartiendo?
Ah, sí, ¿no?
Es que no veo.
Ah, perdón. Pensé que lo estaba haciendo y me salió ahorita. Debo compartir. Ah, ya veo. Perdón. Entonces, ¿ahora sí ven?
Sí, ahorita sí.
Bueno, entonces son tres grandes temas. Uno es los finite state automata. El otro es context free grammars. Y el otro es máquinas de Turing o Turing machines. Y and complexity. ¿No? Entonces, en general, este tema estadísticamente es el más fácil, en el sentido que en el parcial les va mejor. El más complicado es Turing Machines and Complexity. Y este, digamos, es un término medio en cuestión de complejidad. Entonces, para que tengan en cuenta de no esperar hasta lo último para ponerle cuidado al curso. O sea, estos dos, es importante para ustedes que le pongan mucho cuidado a estos dos para cuando lleguen aquí, pues ya estén en una mejor posición con respecto a la nota. Bueno, entonces, ya expliqué más o menos de qué se trata el curso. Para asegurarme de que puedan seguir la clase, voy a hacer un recorderis a cierto background que yo no sé si ustedes tienen, deberían tener, pero si no lo tienen, aquí lo voy a recordar. ¿Listo? Entonces, ahora sí, digamos, pasemos a inglés. So we're going to talk about string and sets. Strings, you know what a string is. A string is a sequence of characters. For example, this is a binary string. The string of 1 followed by 1 followed by 0, 0, 1. So that's string. And this string belongs to the alphabet 0, 1. That means are sequences that are formed from symbols that are either 0 or 1. So then there is the alphabet. So an alphabet is any finite set. It's important that the alphabet is finite. So an example for numbers is the alphabet 0, 1, 2, 9. Every number can be built from symbols of this alphabet. So for example, 92 is a string that belongs to the alphabet 0, 1, 2, 9. So like every decimal number can be expressed as a sequence of symbols from this set. So we will typically use the Greek letter sigma to denote the set of to denote alphabets. Okay, and the elements are typically named as A, B, C, and a typical example of sigma is the binary alphabet. The binary alphabet is the alphabet 0, 1. And this is very important because you know that machines basically work with the binary representation of numbers. So it is the most used alphabet. So then a string over an alphabet is any finite sequence of elements of sigma. So as I said, if the alphabet is, for example, AB, then AABAB is string over the sigma, and its length is 5. So the length of a string is denoted like this. So you have string X, the length is denoted like this. So the length of the string AABBA, which is 5. So there is only one sequence or string of length 0. That string is called the empty string. It's also called the null string, and is typically denoted with this symbol, which in Greek is called epsilon. So epsilon is the empty string, and its size is 0. So one question, have you seen sequence strings before? Have you seen anything about strings before? Anyone?
Yes.
Okay. So it's important anyway to have a common notation to define the concepts of finite state automata. So we really need this. And we're going to write A to the N as the strings that have n A's. Sorry. That means the string with only A's of length n. So A to the 5 will be it's gonna be AA. So you have to use recursive definitions or inductive definitions, and this is a way to define this operation here. A to the 0 is defined as epsilon, and A to the n plus 1 is defined as A to the n followed by an extra A. Do you understand this definition?
Yes.
Okay, so just to make sure that you understand this, what would be the problem if I did this? By the way, if you have problem, you know how to activate the subtitles, right? You can get online subtitles. Sorry. What if I define this like this? So what will be the problem? What will be the problem with that definition? Anyone?
Wouldn't be the A the N followed by 2 A's?
No. The definition I said here is A to the n plus 1 is equal to A to the n plus 2 followed by an additional A.
There is more A's than it should, right?
Yes, there are more A's here than here. Yes, but what would be but I'm trying to define this. What would be the problem? Imagine a program that was defined like that. What would be the problem? You are defining this in terms of this. Is that a problem?
You could rewrite it each time and make it bigger each time, so it wouldn't be an actual equivalence.
Exactly, Naeem, very well. That's very good. So the problem is you keep rewriting this, then this will be n, so this one will be n plus 2, but you need to add it another one, there will be plus 3a, n plus 4a, and that will give you, it will never end. This, however, here you are defining a to the n plus 1 in terms of a to the n. That means that a to the n will be defined in terms of a to the n minus 1 and so on till you arrive to the basic case. And that's well defined. You understand that? Just imagine that was a program. It will be the other one will be a program that is running forever, it will never end. But this one, it will, for a given n plus 1, it will eventually end. You understand? And this concept is very important because it has to do with some techniques that we'll use later. Okay, so the set of all strings over an alphabet sigma is denoted as sigma star. So sigma star of A, B are all these sequences that can be built upon A's and B's. Okay, so it includes the empty one, A, B, A, B, B, A. Okay. So one question. So is sigma is a finite set, right? You know that. By definition, sigma, the alphabet, is always finite. Is sigma star finite too? It's a question. So
I think it's infinite.
exactly. So even though sigma is finite, sigma star could be infinite. That's that you can observe already here. Okay, so this is for sets. There is some exception though. If your alphabet or your set is of symbols is the empty set, by definition, sigma star of the empty set is going to be, it's going to have only one string, which is the epsilons, the empty string. Okay? So remember this is important. Okay, so of course you know that in a set it doesn't matter, the order doesn't matter, but in sequences it does matter. So the set AB is the same as the set BA, but the sequence the string AB is different from the string BA. One parenthesis here. Sometimes I'll say sequences. Sometimes also string, meaning the same thing. It's because in some domains they are called sequences instead of strings. But in calculus, sequences mean something else. So, but if I say sequence, I mean to say strings too. So it's very important that you do not confuse these three things. Does, for example, Juan Luna know that these things are different? 1?
Yes.
So what is this?
So that's an empty
Set?
conjunto. Empty set, yeah.
You can answer Spanish if you wish. It's no problem.
Okay, that's a set with one element.
Which is, yeah, and this one?
Yeah, and that's just the element.
And this is the empty string. And this is the set
Yeah,
that contains the empty string.
Yeah.
So now we're gonna, let me remember. We're gonna talk about some important string operations. And probably the most important is concatenation. The concatenation of X and Y, you write X followed by Y, is string with all the symbols of X first, followed by the symbols of Y. So X followed by Y. And that concatenation is associative, meaning that if you concatenate X, Y, and then concatenate that with Z, is the same as the concatenation of Y with Z, and then concatenating this after X. Okay, is this property clear to you? Okay, the empty string is the identity for concatenation, meaning that epsilon concatenated with X is the same as X, or X concatenated with epsilon is also the same as X. So no surprises there. And the size of X concatenated with Y is the sum of the size of X plus the size of Y. Okay. Now, can you give a definition of concatenation? How would you define concatenation inductively? Inductively, I mean something of this kind. So when you are asked to provide an inductive definition, you should think of the basic case. So you have two strings, let's say X, Y, and basically you want to define what X concatenated with Y is. So what string given X and given Y, what string you obtain for concatenating them? That's what you wish to define. So what would be the basic case? Any suggestions?
The empty string?
Yeah, so, but there are two strings, so yeah, it's the empty string, but how you start here? Tell me what to write. You mean like this? That could be a choice.
Yes.
Okay. And then X concatenated with the empty string is equal to?
X.
Very good. And then you say X concatenated with
Y.
But then what you write there?
XY.
Sorry? No, but no, because then you are defining in terms of itself. I want to define the operation of concatenation. I mean, sometimes concatenation should be written like this. Sorry, like this, but you become lazy and you just write like this. I mean, you forget to write this thing. But that's what we intend to define.
Ve, profe, ¿y no sería equivalente poner pues la definición como X y el empty y Y con empty? No sé si me hago entender.
So try. you could.
Como,
Mhm.
como la segunda parte que hice como X con vacío, pues la
Ujú.
definición es X, entonces plantear como de pronto la misma definición, pero con y vacío, y así obtener, digamos, como XY.
Yeah, that might work. Maybe you are defining something like this, probably. But let me try instead. Suppose that this is, what will be the concatenation of X with a string that starts with A followed by Y? Any suggestions?
It will be
Mhm.
XA concatenated with Y.
Exactly. And now, first question, why this definition is well defined? Why doesn't, remember the problem with the previous definition that will go on forever? So this one doesn't go on forever. This one will terminate. Terminate means that eventually you will get to the basic case. Can someone tell me why?
Because eventually that Y will be an empty string.
Exactly, because of that. Very well. So this is one way to define this. Can someone find another way? So this will be the definition of concatenation. Any suggestions?
Maybe defining X as maybe as a string, but I don't know. Defining better. Well, I will define better X, A, and Y. Oh, well, actually, we defined it previously, so there's no need to it. Sorry.
Okay. So, but you could also do it like this, right? The empty with Y is defined as Y. And then you say you are basically doing induction on the first argument. So you say it is string A followed by Y with Y. You will be, no, this wouldn't work quite well. Sorry. X with Y will be, how would the, what will be the left, the right side of this equation?
It's concatenated with A and Y.
Exactly. Okay. And again, this terminates because this X eventually will become empty every time. Okay, so we continue with this. And now I want you to define this operation recursively. I mean, how will you define using similar ideas like this? You want to define the size of X inductively. So what will be the basic case? The length of, or the size of?
Size
of Epsilon.
a single character.
Mm-hmm.
Epsilon.
What will be defined? Like, what's the size of epsilon, do you think?
0.
Mm-hmm. And then what will be the size of A followed by Y?
1 plus size of Y.
Perfect. Yeah, so now I think you understand very well this concept. So this is a good exercise here. So we're gonna write x to the n. Notice that this x is a string now. Sorry, I forgot to say, normally A, B, C, D are gonna be symbols, and X, Y, Z, W, they're gonna be normally strings. So X here is string. X to the n is the string X concatenated with itself n times. So AAB to the 5 is AAB 5 times. Okay? And then following these inductive definitions, x to the 0 is epsilon, and x to the n plus 1 is x to the n followed by x, but similar to what we did before for symbols. Now another definition is number a in x. This is the number of a's that appear in x. In this example, for example, the number of zeros that appear in this string is 8. 1, 2, 3, 4, 5, 6, 7, 8. So one question, one exercise is define this inductively. So anyone?
Sería
So numbers of a's of in epsilon is what?
Si lo que se lee es A, entonces sería 1 más.
No, wait. But when you think of an inductive definition, think of the basic cases first. Did you see what I wrote in the screen, or?
Entonces ahí sería 0.
Exactly. And now you had an idea saying if what I'm reading is A, so this you can do as follow. What you said can be done as follow.
Y x es igual a 1 más la inductividad sobre x.
Which is?
The number of a's.
Mm-hmm. And this one?
Asterisco, numeral A, x.
And normally just you say, okay? Or not if, sorry. It will be better if you actually say where A is different from B. Okay? So that would be a way to define that. So the notion of prefix. A prefix of string X is an initial segment of the string X. So basically a string Y, for example, if the string is of the form YZ, then Y is a prefix of X. Okay? So basically Y is a prefix of X if X can be written as Y concatenated with something else. Is that clear? Is that clear or not?
Yes.
No.
Okay. Who said no? Angelo? Okay. So Angelo, basically you say as y is a prefix of x if there exists, I suppose you already saw logic. If there exists, we're gonna write it in English. If there exists a set such that y is equal to y concatenated with z. So this is the definition of prefix. Let's see an example. So example 0, 1, 1 is a prefix of 0, 1, 0, 0. Okay. Why is that? Can someone tell me? Just to illustrate this to Angelo. Then I look to the definition. So apparently y is 0, 0, 1 and x is 0, 1, 1, 0. To see if this is true, I need to find a set such that x is equal to y concatenated with z. Angelo, can you tell me who is, I mean, what string here represents z?
Profe, el conjunto sería 0, 0, ¿no?
The string.
The strings sería 0, 0.
Mm-hmm. So now you understand the notion of prefix?
Sí, sí, ya quedaron más claro, profe.
Okay, so the suffix is proper if it's not the string itself. So that's a nice exercise. So this is a prefix. Question: Is x a prefix of itself?
Yes.
Okay. So how will you define the notion of proper prefix? A proper prefix is a prefix that is not exactly, it cannot be itself. I mean, mathematically, if you use mathematics, how you define it? You say a y is a proper, like y is a proper prefix of x if what?
Maybe you could say if there exists a set that is different from an empty string.
Mm-hmm. Very good. This is set. This is set different from the empty string such that, well done. And then you say proper. Then prefix, then there is the notion of suffix, but it's defined similarly, but at the end instead of in the beginning. So I'm not going to define this. Now we're going to see some properties of sets. Normally sets of strings. So we're going to use A, B, C, and capital letters like this to denote set of strings. The cardinality of the set, that is the numbers of elements of the sets, is expressed like this. By the way, you know about cardinality of infinite sets? You know You know about that? Have you seen about anything about that in your discrete mathematics course or something? So what's the cardinality of the natural numbers?
And by cardinality, do you mean the number of elements in a set, right?
Yeah, if there are finite, is the number of elements, but if there are infinite,
Isn't it like the property of natural numbers? For instance, that they are enumerables. I don't know how to say that
exactly,
in English.
exactly, yeah, enumerable. So, so is the cardinality of the natural numbers equal to the cardinality of the integers? Is this the same? So this
think that,
you know
well,
this set, right?
Yeah.
So
I
this
think
is
that they're
negative.
the same
Yes,
because you can make a injective function between the natural numbers and the integers.
exactly. So this is very important what you said, and I'm gonna more or less try to explain. When you have infinite sets, then you cannot count them anymore. So you need to come out with a notion to say which sets have the same elements as other set, or whether a set has less elements, even if they are both infinite. So you take the natural numbers and the integers. So you of course know this, but we don't have this, right? Then your impression will be that this one is bigger because it contains this one strictly. But there is a way to compare the number of elements by having a function that associates to every element of this set a unique element of this. Therefore, they have the same cardinality because to every element of this one, you can associate an element of this one injectively, as Daniel pointed out. I think was Daniel. Or so basically, what he's saying is here I have the positive and negative. So you have 0 here, -1, -2. Then you have 1, 2. And in this one, you only have 0, 1, 2. So think of a way to associate to every element of this side, a unique element of this side. So this is Z, and this is. Any ideas? It's like a hack, an easy hack. If you can associate to every element.
¿Con el valor absoluto?
Yes, that will work, but not quite well, because that association must be unique. As somebody pointed out already, it must be an injection. If you take the absolute value, then what will be -1 will be sent to or mapped to 1, right? But 1 will be also mapped to 1. So you are not associating a unique element. This association is not injective. You see what I mean? You are taking two different elements and they are being mapped into the same element, and you don't want that. Different elements must be mapped into different elements here to be injective. Am I losing you here, or you understand what I'm saying?
Profe, ¿y elevarlo al cuadrado?
Why would that not work?
Porque no estarían todos los números naturales. O sea, no estarían asociados con todos los naturales.
So no,
No sería,
no, that's
no
not
sería
a problem.
Okay.
Yeah, the second one. So -2 to the 2. What would you mean
4.
-2? 4 and 2.
Ah, okay. Sí. Ya.
So no, I know you can come up with a hack. So Naim, any hack? How you associated it?
No, I'm not sure.
¿Y no podemos hablar solo de hacer una restricción de dominio?
Keep on. What you mean?
Pues no sé, no mentira, eso sería descartar todo el conjunto. Decir
Exactly.
que,
No, you cannot do that. You want to associate at every element from here a unique element here. So every two different elements. So that's the only way that you can convince anyone that there are enough elements here to cover all the elements from here. Because if you, I mean, otherwise you can just send all of them to 0. And that wouldn't work, right? Yeah, somebody was talking, sorry. So could you? Juan.
I was thinking about maybe trying something, but it's kind of weird. Like assign the 0, the 1, and from then on, the positive numbers add 1, and the negative numbers times -2, and I think that will solve the problem. I think. I'm not sure.
So you say the 0 goes to 0.
Oh no, wait, that wouldn't work. Never mind.
Okay, so I'll give you a hint. Try to find two infinite disjoint sets in the natural numbers. I mean, two infinite sets that are subsets of the natural numbers. Do you understand what I'm saying?
Profe, creo que tengo una idea. Podríamos tratar de que los números pares fueran sucesivamente siendo los números positivos de los enteros y que los impares fueran los negativos.
Exactly,
Entonces,
Simon. Exactly, that's what I meant. That's what I meant with my hint. Simon has just identified two infinite sets, that is, the even numbers and the odd numbers. They are both infinite, they are both disjoint with each other, and they are natural. And that solved my problem, because what he said was send positive to, let's say, even numbers. So 0 goes to 0, 1 goes to 1, 2 goes to 3, 3 goes to 5, and -1 goes to the first even number, -2 goes to the second even number, and so on. Voila, here you see, you have it. So you will find a natural number here for a unique one for every number here. Did you understand? Angelo?
It would be like a operation with cases then.
Yeah, yes, for sure. It could be any operation. It's just that's a well-defined function. So, I mean, you just need to multiply by 2 and add a number if it's negative or if not, or it's positive. So, but this just shows that the cardinality of these two are the same. And of course, you might wonder if you can do the same for other sets. And the question is, no, you cannot. And for example, the real numbers do not have the same cardinality as the natural numbers. So, in fact, the continuum hypothesis tells me that the real numbers are the first uncountable set, or the smallest uncountable set, meaning that it's a set that cannot be put into a map like this with the natural numbers. Okay, that's just talking about cardinality. It's something that you should know. So, okay, going to more basic things, you know what the union of sets is. The union of sets is all the sets that are in one or the other. Intersection is the set of all X such that X is in A and in B. And the complement in sigma star of A are all the strings that are not in A. So, for example, the complement of all the strings that have even length will be all the strings that have odd length. This one is more interesting, which you probably didn't know. A concatenated with B. A concatenated with B are all the sets, all strings of X concatenated with Y such that X is in A and Y is in B. Okay. So one question. Is A concatenated with B the same as B concatenated with A, where A and B are set of strings? Santiago?
I think not.
Yeah, it's not, because the order matters, right?
Yeah.
This other question. What will be the concatenation of these two sets? Here's the definition if you want. Isabela? Isabela?
Hola, profe.
What's the concatenation of these two sets?
¿De cuáles, profe?
They're on the screen right now, these two. Okay, I don't hear Isabella. Someone else?
Profe, no sé.
Profe,
¿No
no entiendo la
sería...?
pregunta. ¿Distributiva, más o menos?
Sí, ahí se aplica como una distributiva, ¿no?
I don't know if I mean, look, this is the definition, but I'm asking what set, if you concatenate these two sets, what's the set that results from that concatenation? You see, this is a set. So what will be the set?
Teacher, I have a
Mhm.
question.
Huh?
Concatenating sets is like making the Cartesian product of two sets, but instead of making pairs, you are concatenating strings.
This is a tricky question, and this is coming next. A good question.
Okay.
It's going to be a homework.
Okay.
But just wait for a second. But I mean, here's the definition. Suppose that this is a computer program. It's telling you how to compute this set given A and B. Is all strings such that the first string is in A and the second is in B.
Well,
I mean,
I think that
all the concatenations. Sorry.
the elements of AB will be, for instance, AB, ABA.
Wait. AB.
AB, then ABA, then ABB.
Sorry. There's a problem with my iPad. So again, AB and then what?
ABA.
One at a time. ABA, and then?
Then ABB.
Mm-hmm.
ABBA.
Exactly. And you get it. Now, so is that clear, right? That's clear now. So now there was the question of the Cartesian product. Then let's see the Cartesian product of these two. What's the Cartesian product of A, B, B, A?
I think it will be the first pair will be A, B. The another pair will be A, BA. Then it will be AB.
Oh, no, sorry, I made a mistake. And then AB,
B, and then AB, BA.
Yeah. Okay, so as you can see, there are different sets. The Cartesian product, you have pairs. In this one, the elements are pairs of strings. In this one, the elements are strings. Okay. Although you might wonder the following question, now that you know this. So is the cardinality of A concatenated with B the same as the cardinality of A Cartesian product with B? So what do you think? Homeworks in the material will appear in red with the HW mark, okay? You know that you have to prepare this for the next class because you might want, I mean, you might want to volunteer to present the exercise, or you might be chosen at random to present this exercise. So do you understand this question?
Disculpe, es que me tuve que desconectar por el internet. Entonces, ¿cuál sería la pregunta?
If the cardinality is the number of elements of A concatenated with B is the same as the cardinality of the Cartesian product between A and B.
Okay.
Okay. Okay, this is because somebody asked about Cartesian product. Okay, I continue with this. Let me see how much time do we have. Yeah, I think we have to. So then you can again do this power of, we did powers over symbols, powers over strings, and now powers over sets. So suppose that A is a set. A to the n is defined as this. A to the 0 is the set that contains the empty string. A to the n plus 1 is A concatenated with an. So as an example, is given here. A to the 3 is A concatenated with A concatenated with A. So as an example, AB concatenated, sorry, AB, AAB, that set to the square is this set. So you see why, right, or not? Because this is the same as AB, AAB, concatenated with AB, AB, AAB. So you have AB, 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 AAB. They go AAB, AAB, and AAB, AAB. So that's it there. Okay, so here there is an more difficult definition. A star, asterisk A also, is the union of all sets of the form A to the n. That means A to the 0, union A to the 1, union A to the 2, union A to the 3, and so on. Okay? So it's this big union here. Another way to define this is to say that A asterisk A is x1, the set of string of the form x1, x2, xn, where n is bigger than 0, equal to 0, and each of these strings belongs to A. Okay, so one homework is to show that these two definitions are the same, and is a homework that requires some work. So there you have it. And sorry, A plus is similar to A star, but you do not notice that what is it? Ah, yeah. Notice that A star includes A to the 0, and A to the 0 by definition is, in case you have forgotten, is this one. And it's defined here. So A plus is A concatenated with A star. That means sorry, that is the union of all A to the n, but you do not include the case n equals 0. So you start with n greater or equal to 1. So then it's easy to see that A star is A plus union with what? Anyone?
Epsilon?
Yes, no. The
A
set
to
that
the
contains
0?
something. Yeah, exactly. Which is A to the 0. But do not set epsilon, because epsilon is different to the set that contains epsilon. Okay.
Sí.
Okay, so you know unions, intersection, and concatenation are associative. But that's clear. And union is commutative. The empty set is the identity for the union. The set which contains only epsilon is the identity for set concatenation. Do you see why? Oops, sorry. Do you see why? This is true or not? Okay, so try to think about that.
It's because when you're concatenating sets, it will, for each one of the strings in the set, it will concatenate each other. So because concatenating the empty string to another string is like commutative for every string. So I think that will be the reason.
Yeah, exactly. And the empty set is the annihilator for concatenation. You see why or not? This one. One. Juan Luna.
Yes, sorry. I missed that.
This. Why is this the case?
I don't know. Sorry.
So you may have missed also the definition of string concatenation.
Yeah, I think I missed that. I'm sorry.
Okay, so please don't do that because I'll be asking at random, and this the monitor is actually grading your participation. So try to be focused during the class. Okay, so here for you, A concatenated with the empty set is all the strings x, y such that x belong to A and y belong to the empty set. Now, since no string belongs to the empty set, then the whole set will be empty too. You understand now, Juan?
Yes, thank you.
Okay. Okay. Union distributes over intersection, and intersection distributes over union. And set concatenation distributes over union, meaning that A concatenated with B union C is the same as A concatenated with B union A concatenated with C. However, it's not the case that A concatenated with B intersection C is not always the same as A concatenated with B in general. A concatenated with C. In general means that there are A's, B's, and C's such that this equality does not hold. So the question is, can you give me a counterexample? Can you find a set of strings A, a set of strings B, and a set of strings C such that A concatenated with B concatenated with C is not the same as A concatenated with B intersected A concatenated with C?
Profe, el único caso en el que se podría cumplir eso es que B y C sean iguales, ¿no?
Yes, that will work. But it's not the only case. There are lots of cases where it holds, but in general it doesn't. So what I want you to find is 3 sets in where that's not the case. Okay, so I'll give you 5 minutes to think about it. Or you have the counterexample now. So do you understand the question? So let's say Diego Andres, do you understand what we're asking here? Diego Andres Vinasco Trujillo?
Yes, yes.
So try to think. I mean, you can talk among yourselves, or I don't know, WhatsApp or something. And in 5 minutes, we look into this, okay? Okay, I'm back. Tell me, anyone found a counterexample?
I have one, teacher.
Excellent. So let's look into that.
So every
wait. Just let's say, so A is equal to what?
The set is compound of A, comma B.
Mm-hmm. That's it? A?
Yes.
And B?
Yes.
And B?
C, comma D.
And C?
E, comma F.
E, comma F.
E.
So this part was A concatenated with B, C.
It's A, C.
Okay, wait, let's do it step by step. So it's good to do this intersection first, right? B intersected with C.
It's empty.
It's empty, so you know that this is empty already.
Yeah.
Okay. And now A concatenated with B.
Okay. It is AC, comma, AD, comma, BC, comma, BD.
And A concatenated with C.
It's AE, comma, BE, comma,
Wait. AE, AF, I guess. And
yes.
then BE, and then BF.
Yes.
So what's the intersection of these two?
It's empty.
But then it's not a counterexample because they're actually the same.
But the first part, A concatenated with B intersection C, is empty. An empty. Oh, I mean, we had to find an example where they were equal, right?
No. You need to prove that this is the case, that these in general, they are not the same.
Oh, okay, my bad.
It's all right. But I understand what you're trying to do was the opposite, to find a counterexample but that wouldn't be a counterexample of this because I did not say here that for all A, B, and C, this was not equal. I say that in general. In general means that there are some exceptions, but it's not always the case. In other words, in general, if you don't understand what in general means, basically when you say something in general is not the case, you say that there are A, B, and C such that this happens. Okay? So to prove that this is the case, then you need to find A, B, and C where this is not the case. But Simon, that was a good example anyway. So, okay, so I'll give it to you as exercise, okay? I'm sure that you will be able to find this. Okay. Then you need to remember also the Morgan laws. Have you seen the Morgan laws before, Angelo? That the complement of A union B is the intersection of the complements of A and B and stuff like that?
Profe, la pregunta era que si habíamos visto las leyes de Morgan antes.
Yeah, exactly.
Sí.
All right. So then some properties of this asteroid operation. A star concatenated with A star is the same as A star. It's also idempotent, meaning that A star star is the same as A star. And very important, the star of the empty set is not the empty set, is the string the set that contains the empty string. And this is just because, remember that you have A0, A1, and so on. And this one, by definition, is this one. So, okay. I'm going to give you an exercise that if you do it, you solve it, you have the highest grade in the first partial. That means that you do not have to present the first exam. Are you paying attention?
Yes.
So you solve this and you solve it well. So this is the question. It's only sets, so you're gonna define this operation. A plus B. Okay, A plus B is equal in general to and A and B are set of numbers. It's not a set of strings, it's a set of numbers. Natural numbers if you wish. Or let me put it like this. Integers. So are all the sets of x plus y such that x is in A and y is in B. Any questions about that definition? So for example, what is this set equal to? Simón?
3,3.
3, no.
No,
3,4.
3,3.
Yeah. Has two elements and one is 3 and 4. Okay. So, sorry, I should have. Here is the first question. And this is very important. I'll tell you later why these operations are important. They are the fundamentals of computer representations of graphics. This is something called erosion, but I'm not going to go into details now. I want to confuse you with that. And this operation is called, dilation. You want to look it up on the internet. But I want you to show that in general, well, actually, I'm going to put something simpler. First, this is always the case. It's the same as what you saw before. A plus B union A plus C. That means that the plus operator distributes over union. So show that for all A, B, and C in the natural numbers, this happens. Okay? But
¿Puede ser solamente con un ejemplo que satisfaga la ecuación?
no, that's not show. That's because then I just take the empty sets, all of them, and then that satisfies the equation, right? So no, of course not. You have to show that for every A, B, and C, okay, from the definition. Now, so the plus distribute over union, but it does not distribute over intersection. That is, show that in that there are A, B, C. Actually, I'm gonna put here. It's easy. You have the set. The integers to who asked the question before about if enough to show an example?
Angelo.
Hello? Angelo. Oops, something happened. The screen disappeared, right?
We can't see the screen.
Yeah, I don't know what happened. Wait. Nicolás, can you hear me?
Sí, señor.
Okay. I have a problem with. Sorry, I need to connect again my iPad to my computer. Okay, now share. Okay, now you see my screen again, right?
Yes.
Okay, so this is important. When you're gonna show that something it is true, then you show an example is not enough. But when you're gonna show that something is not true, I mean that this is not the same as this, then an example is enough. So you give me an example of A, B, and C, subsets of the integers, where this is not the same as this, then you have shown this. Because you just need to show that there are A, B, and C, such that this is different from this. So an example that in mathematics is called counter example, then suffices. You understand what the difference is?
Que en la primera nos toca mostrarlo en general y en la segunda con un contraejemplo es suficiente.
Exactly. A counter example that these two are the same. Okay. So,
sí.
Okay. And this is the one that actually, I mean, this one is easy. This one is easy, you think enough, but this one is not that easy. I think it's not. Therefore, this one is the one that gives you the highest grade. That's a 5 in the first exam, which is the following. So I hope not to make a mistake here. A plus B and C is not the same as this, but is the same as this. A big intersection of all y's that have subsets of A, and then you take y plus B union y plus C. Tell me, Wait, let me be a little bit more organized with this. I'm gonna move this a little bit here. So you're gonna show that for any A, B, and C, this is the case. Do you have any problems with reading this equation? You understand it?
Teacher, for the second one, we just have to show one example, A, B, and C.
For all. When you have a for all, it's not enough with an example.
No, I mean in the second question.
Ah, yeah, there are.
Just one A, B, and C, and that's all.
Yeah, if you say there are, it means that with one is enough. Okay?
Okay.
So that's the difference between existential and for all.
Teacher, I think there's a little
typo.
Typo, yes.
Yeah.
In the second part, there is A plus B intersection A plus B.
Sorry. You mean here? Oh, yeah. Very nice. Good. Do you see any other problems? So, do you understand this notation?
En la última, en la notación de la intersección, en la parte de abajo, es que no alcanzo a ver. Ah, ya. Es Y que esté contenida en A, ¿cierto?
Sí. So, it's the intersection of all Y's, every Y that is included in A, of this Y plus B union Y plus C. So it covers all this. So for all Y's that are in A, you do this, and then you intersect everything. Any questions with that equation? Any other questions? Something that you don't understand?
Teacher.
Profe, en la segunda, perdón.
Are you gonna exonerate anyone that do that, or only the first one?
No. I mean, these ones are easy. This one is not that easy.
Yes,
so
only the first one?
No, well, it's kind of difficult, because if I said everyone and someone does it that distributed overall, then yeah, so it must be the first one. In fact, just like make it better, groups of two people, the first group. Okay, but only the first group.
Profe, ¿y te la tenemos que enviar o te la mostramos la próxima clase?
The first one who sent it and is correct, then it will be so, and it's easy. You send it through Teams, and I suppose this is a question for Nicolas, that Teams has a time tag when you send the message, right? Or not?
Sí.
You send a message, appears the time when you send the message or not?
Sí, señor.
So, okay, so the first message that arrives with the right answer, then the thing is, to do this one, you need to have done this one.
La idea no sería darle hint a los otros. Entonces, yo monté una tarea para que los muchachos subieran fotos y eso. Y ahí igualmente aparece la hora.
Okay, good. So, okay, I'm gonna pass to Spanish now. Bueno, aquí termina la clase. Ahí dejé unos ejercicios generales que les puedo preguntar. Y este último ejercicio o estos en total, si alguien soluciona todos estos ejercicios bien, en particular este, tiene 5 en el primer parcial. Es decir, queda exonerado del primer parcial. Ustedes tal vez...
Pero es el primero que lo envíe, o sea, el primero que lo envíe bien.
Claro, porque si no, entenderás que no tiene sentido si todos pueden, porque digamos que alguien lo haga y lo distribuya, entonces todos tendrían 5, entonces no podría hacer el examen a nadie.
Entiendo, profe.
Entonces tiene que ser el primero. O lo podemos hacer sin grupos y entonces puedes ir los primeros 2 o los primeros 3 o algo así.
Yo creo que mejor el primero. Igualmente, no creo que eso llegue así tan pronto, pero pues no se sabe.
No, pero yo creo que sí es mejor como en grupos.
Bueno, entonces hacemos en grupos de 2, el primer grupo que lo envíe. Ya. Una cosa es, seguramente esto no, ese último no lo van a encontrar en ningún lado, en internet o en ningún lado. Es un ejercicio que no aparece absolutamente en ningún lado. Es decir, es un ejercicio que yo me inventé.
Ay, Dios.
Entonces, no pierdan el tiempo buscándolo en internet. Pero sí es algo que existe. Pero no el problema, no el teorema como tal, ¿sí?
Qué pena. Una pregunta rápida sobre el último. Estas son todas las intersecciones de todos los Y, donde esos Y son todos los subconjuntos posibles de A, ¿cierto?
Sí, exactamente. Entonces,
ok.
Entonces, si el conjunto, digamos que el conjunto sea... Esto fue una pregunta, supongamos que ¿qué es esto? 1 más... Este es un ejemplo muy simple para que veas este, ¿cierto? Según ese teorema, esto debería ser igual a la intersección de todos los subconjuntos que están en A. ¿Cuántos subconjuntos hay en A? Perdón, en este A, 2, ¿cierto? ¿Cuáles?
El vacío y el 1.
Entonces el vacío del 1, exactamente. Entonces vamos a ver, entonces sería la intersección de Y cuando Y es igual a vacío, entonces sería vacío más B unido. Acabo, acabo de encontrar un error. Menos mal me hicieron esa pregunta. Y concatenado. A menos Y plus C. Esto es resta de conjunto, ¿lo conocen? Este es A menos Y. ¿Saben qué es A menos Y?
¿Cómo subtraer?
Sí, exactamente. Es este conjunto, pero le quitan este. Entonces, aquí es Y y aquí es A menos Y más C. O sea, los paréntesis van, si quiero ser estricto, sería así. Bueno, entonces, aquí me daría vacío más B, porque Y es igual a vacío. Y aquí me daría ¿qué? ¿Qué sería A menos Y aquí? ¿Alguien? A es 1, el conjunto que tiene el 1. Entonces, ¿qué me queda? Y Y son 2, vacío o A. Entonces, ¿qué me daría esto?
¿1? ¿No?
Sí, exactamente. Entonces, A, pues que es 1, entonces digámoslo A. Este es A. más C, intersectado con el otro caso. Ahora Y es A. Entonces, ¿qué me queda aquí? A más B unido con ¿qué me queda aquí ahorita?
Con vacío más C.
Exactamente, muy bien. Con vacío más C. Esta vez cierta simetría, ¿no? En este tenemos vacío más B y aquí tenemos vacío más C. Y aquí tenemos A más C y aquí tenemos A más B. ¿Sí ven o no ven esa simetría?
Sí, profe.
¿Ahorita entendieron de qué trata la intersección sobre todos los subconjuntos? Este es un ejemplo. Bueno, y...
Profe, otra pregunta con respecto a la entrega de la prueba. ¿Se tiene que hacer una entrega, o sea, se puede tomar foto al papel donde se hizo la prueba o tiene que estar bien escrita en un documento?
Pues no, bien escrita.
Ya, ok.
¿Ustedes saben utilizar LaTeX?
Pues ahí sí.
Entonces, escríbanlo en LaTeX. Sí, tienen que acostumbrarse a utilizar LaTeX. O sea, no
Frank,
pueden... ¿Ah?
para la
¿Qué?
del parcial, ¿el plazo también es hasta el lunes o es hasta dentro de 8 días?
¿Cuál parcial? Ah, perdón, el plazo para
Este
entregar
ejercicio,
este ejercicio 8 días. O sea, de aquí
8
al otro
días.
viernes. Una semana.
Ok.
Yo les aconsejo a los que les guste, hay una estrategia que utilizamos mucho los que hacemos ciencias de la computación, es uno escribe un algoritmo. Uno escribe un algoritmo que calcule esto y calcule esto, que es muy fácil. Aquí están las definiciones. Aquí dice que es A más B. En Python lo escriben en un momentico. Python tiene intersección, unión. Y empiezan a generar conjuntos al azar, que sean subconjuntos de los enteros, y ensayan. Y ustedes miran, se cumple, no se cumple, o se cumple por esto. Lo mismo para este. O sea, por ejemplo, este lo pueden solucionar facilito haciendo lo que les digo. Generan conjuntos aleatorios y verifican si esto. Y seguramente Python les va a encontrar uno de esos donde no se cumple y ahí ya tienen su contraejemplo. En este, pues a no ser que me haya escrito algún typo por aquí, algún problema sintáctico, pues no va a pasar. Pero digamos, la ejecución del programa les puede dar intuición de por qué es cierto. Sí.
Una preguntita. Donde subimos la tarea, ¿es solo si vamos a hacer esta parte o el resto de las preguntas que están más arriba también las subimos?
No, las preguntas de allá son tareas y esas tareas no tienen que subirlas a ningún lado.
Como para
Simplemente, sí, eso es para que practiquen ustedes y el hecho es que yo sí puedo hacer esas preguntas en la próxima clase. ¿Me entiendes? Estas de acá, estas que tienen, esta no la marqué con homework porque no es una tarea. Le voy a poner un nombre de una vez. Voy a poner este problema que está aquí con este disco no es una tarea, es opcional para aquel que quiera hacerlo y ser exonerado con un 5 del primer examen. ¿Ya? Los demás son tareitas, algunas más difíciles que las otras, que son para voluntarios, pero si no hay ningún voluntario, entonces ahí sí toca que llamar a alguien y el que no conteste, pues Nicolás está anotando todas esas cosas, quién participa, quién no. Todas estas participaciones que han estado haciendo, por ejemplo, no sé, digamos, Juan ha estado muy activo, Ángelo, Naim, Simón, si se me olvidó alguien, disculpen, de todas cosas,
Santiago.
Nicolás, Santiago también. Entonces ellos ya van teniendo ya puntos adicionales con diferencia de los demás que están más callados. Entonces estas tareas les ayudan a los que están más callados a decir, en la próxima clase, profesor, yo hice esta. Entonces ya tiene otro punto ya. Esa es la idea de las tareas.
Eso les iba a decir, muchachos. Recuerden que la participación tiene el mismo valor de un parcial, entonces es bastante importante. Ahorita les mando el enlace del video en YouTube y quería preguntarles que cómo iban con el inglés. ¿Sí se está entendiendo o no?
Tiene también los subtítulos, ¿no? Pero no sé si les salió.
A mí me
Pues
parece
por
que en
mi
inglés
parte yo
está
puedo decir que
bien.
sí.
Bueno, listo.
Ok.
En todo caso, miren el video con los subtítulos, que aunque yo no sé, Nicolás, cuando estoy compartiendo pantalla, ¿también pone los subtítulos allí o cómo es la cosa? Que la otra vez
No sé.
ensayamos sin compartir pantalla.
Sí,
¿No?
profe. Sí, pues depende de cada, digamos, participante que quiera los subtítulos. Se puede hacer, digamos, compartir pantalla o todo eso y en la parte de abajo le aparece uno los subtítulos.
¿Alguien lo hizo? Porque pues
Yo, profe.
la mayoría hablan inglés. ¿Y salieron?
Sí,
¿Y se entendían los subtítulos?
algunos. Hay otras partes en que, pues, simplemente como que parabas de hablar y ¿cómo se dice? La transcripción queda
Ajá.
mal, pero pues en sí es como se entiende lo que
Bueno,
decías.
excelente. Eso espero que haya quedado en el video. O no sé si tú lo grabaste, pero bueno, ya veré ahorita que suba el video, Nicolás. Pero me alegra saber que tú lo puedes ver con subtítulos y tú lo puedes ver con subtítulos. Qué bien. En todo caso, si tienen problemas, me escriben utilicen el chat privado si tienen problemas personales. Y si son cosas más técnicas de la tarea o algo así, sí el chat general. Eso sí, la tarea de esta, con la solución a este ejercicio, ya Nicolás les explicará cómo hacerlo. Mucha suerte, muchachos, que tengan un buen fin de semana. Nos vemos en la próxima clase.
Gracias, profe.
Muchas
Chao.
gracias, profe, que esté muy bien.
Hasta luego.
Gracias, hasta luego.
Chao. Gracias, profe. Chao.
Ve, Nicolás, ¿sabes si te puedes conseguir el documento del profe?
El cosito que escribió.
Sí,
Sí, de hecho él lo sube ahorita
sí. Bueno, súper.
en el canal de material. Lo sube. Igualmente,
Listo.
espérate, yo le escribo un recordatorio.